Hello guys, in this video I am going to explain the solution of this question number 7 from chapter 8 of book Engineering Circuit Analysis by Hayt, Kemmerly and Darwin. The question says that with the assumption that the switch in the circuit of figure 8.54 has been closed a long time, means this switch was closed for a very long time. So we need to calculate IL at the instant just before the switch opens. So we need to determine that if this switch, if it is closed like this, then what is the value of IL? Means what is the value of IL before opening this switch? So to determine this, what we need to do, we will redraw this circuit with the position of the switch as closed. So if I redraw this particular circuit, then it is over here, this is the switch, right, in closed state, and right, it is 300 ohms, it is 220 ohms, right, and this is 2 millihenry. This is IL, right. Now over here we know that, and this is 4 milliamperes. Now from the knowledge of the inductor and the capacitor, we know that the inductor, let me write, inductor can be replaced with short circuit, if the current if the current flowing through the inductor is not changing. How? Because we know that V is equals to L di by dt, and if the current is not changing, means this expression, it will become 0, and if it becomes 0, it will be L into 0 equals to 0. So our voltage will be 0 volt if the current is not changing. And if the current is not changing and if the voltage is 0, then it means that this inductor, the voltage across it is 0 volt. It means that it can be replaced simply by a short circuit, because we know that over here in the short circuit the voltage is 0 volt. So from this reasoning, what we can do, we can replace this inductor with a short circuit. So if I replace this inductor with a short circuit, then it will be like this, and my circuit, it will be like this. But remember, we are replacing the inductor with a short circuit does not mean that we do not have the inductor over here. It simply means that the voltage drop across the inductor is 0, and just for the analysis purpose, I am just replacing it with a short circuit, but inductor still exists over here, right? Now if we look at this circuit, now these two resistors, they are bypassed with this branch where we have the inductor. So it means this 4 milliampere current will not go over here, it will not go in this branch. All the current will just come to this short circuit path, because current has the tendency to follow the minimum resistance path. So all the current will come through this. So it means, from this reasoning, it means that this 4 milliampere current, it will flow through this branch where we have the inductor, and our IL, it will be 4 milliampere. So when the switch is in a closed state, in that case the current flowing through the inductor, it is 4 milliampere. So this is answer to the first part of the question, which is saying that what is determine the ILT, means the current through the inductor just before the switch opens. So answer is that our ILT, it is equals to 4 milliampere for t less than 0. Means t less than 0 means that before the switch is opened, right? So before the switch is opened, current remains constant and it is 4 milliampere. Now when the switch is opened, means that this switch, it is going to open. So when this switch is opened, let me redraw this circuit just. So when the switch is open, now what is the condition? Over here we have this condition. We have the current source, this is 330, this is 4 milliampere. Then we have this switch, and the position of the switch is this. After opening, this is 220 ohm, and this is our 2 millihenry, and this over here we have a current IL. Now in this situation, if you look that this part of the circuit, it is disconnected from this part. So this two, once the switch is open, then these two are not connected, and means the current will not flow from this part to this part, right? So means this is not now this part is not connected with the battery with a 4 milliampere source. Now from where it will then get a current? This part of the circuit, it will get a current through the energy that is stored in the inductor. How the energy is stored? Energy is stored because of this condition, that the current was there through the inductor at t equals to 0 seconds. So before the switch was opened, current was flowing through the inductor, and as per the formula, energy storage formula, we know that it is energy stored is this. It means that this amount, like half into 2 power 10 power minus 3, because it is millihenry, into I is 4 milliampere. So 4 into 10 power minus 3 square. So this amount of energy is stored in the inductor. So once the battery is disconnected, now this amount of energy will be used. This energy will try to maintain this IL current, and this is the property of the inductor, right? So with this energy, inductor will try to maintain the current, but obviously it is not able to maintain the current, and it means that we are going to write the equation for this IL with respect to time. And we know that for this type of the circuit, means it is simply the RL circuit, right? RL. We know that for this type of the circuit, we have the expression that IT, it is equals to I naught e power minus R by L T, right? R by L T. So comparing this standard form with this one, over here our R, it is 220 ohms, L it is 2 millihenry, which is 2 into 10 power minus 3 henry, right? So substituting, and our I naught, it is the I naught, it is the initial current at t equals to 0, which is this 4 milliampere. So substituting all these values, we will get I equals to 4 into 10 power minus 3, right? E power minus R, it is 220, L it is 2 into 10 power minus 3, right, into T. Now solving this, simply we will get IT is equals to 4 into 10 power minus 3 e power minus this. So this is the expression of the current that is going to flow through this inductor IT, right? And slowly this current is going to decay as represented by this exponential decay function. Now the question, if coming back to the question says that in the P part, the question says that we need to determine, over here let me change the color. So the question says that we need to determine ILT the instant just after the switch opens. So just after the switch opens means at t equals to 0. So if I substitute t equals to 0 in this equation, if I substitute t equals to 0, then what I will get? I will get I0 is equals to 4 cross 10 power minus 3 e power minus this. So it is simply this, or 4 milliamperes. So current at 0 second it is 4 milliamperes, or the current just after the switch opens it is 4 milliampere. So the answer to this question, it is answer to B part, it is ILT, it is equals to 4 milliampere. Now the third part, it is asking that we need to determine the ILT, means the current through the inductor at this current 15.8, 13.5 microseconds and 78.5. So for the C part, 15.8 microseconds. So simply we need to substitute the value, means 15.8. so at t equals to 15.8 microseconds, means 15.8 into 10 power minus 6 second. Our I will be equals to 4 into 10 power minus 3 e power minus 11,000 into t. T is this 15.8 into 10 power minus 6. Solving this, we will get I at 15.8 microsecond. I will be equals to, over here if you solve this using the calculator, so you will get this, or 703 point something, let it be 12 microampere, right? So something like this. Now again the D part, this is the C, answer to the C. Now the D part says, again, we need to determine the current at 31.5. so again doing the same thing, T is equals to 31.5 microsecond. It means 31.5 into 10 power minus 6 seconds. So at this time, if you substitute the value, you will get, if you substitute the value in the expression of the I's, you will get 0.125 milliampere, or 125 point something, let it be 12 microampere, right? So this is answer to the D part, where at t equals to 31.5. Now E part, over here in the E part, the time we need to determine I at t equals to 78.8 microseconds. Now again substituting, this is 78.8 into 10 power minus 6 seconds. Substituting this 78.8 into 10 power minus 16 in the expression of the current, in this expression, we will get the current, as 0.688 microseconds, right? Now you can see, if you look at this C, D and E part, like you can see initially the current is this, at 0 it is 4 milliampere, right? It is 4 milliampere, or we can say that it is 4000 microampere, right? So initially it is 4000 microampere. Then after 15.8 microsecond, the current reduces to 703. So from 4000 it will reduce to 703, and then at 31.5 microsecond, means as the time grows, so it current reduces from 703 to 125 microampere, and then further, after some time, after few more microseconds, current reduces further, and now it is this 6.68 microsecond. So with this, like if you like calculate these answers and if you apply your reasoning, then you will find out that the theoretical concept is exactly matching the numerical answers. And with this theoretical reasoning, you can try to verify your answer, right, if you have done a correct solution or not. So With this, I end this video. If you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.